Okay, good day. I'm Dr. Eunice at Gizi. I'll be taking the course Food Biochemistry. The course codes are NUD226 and HSM 44422. Um, this course is being taken at nutrition for nutrition students at 200 level, while it is taken for home science and management students at 400 level. For week one, we'll be looking at carbohydrates. At the end of this course, it is expected that, or at the end of this week one, it's expected that students are familiar with Fisher projection of a monosaccharide and they can classify it as either being aldose or ketose. Then it is also expected that students are familiar with Fisher projection of a monosaccharide and can also classify it by the number of carbon it contains. It is also expected that students are familiar with Fisher projection of a monosaccharide and students are able to identify the D or L sugar, then as well as identify chiral carbons and determine the number of stereoisomers that are possible. It's also expected that the students are familiar with the types of monosaccharide derivatives and can predict the products when monosaccharide reacts with reducing agents or with Benedict's reagent. It's also expected that students can define the term anomer and explain the differences between alpha and beta anomers, understand and describe Mutter rotations, give Howard projections, and identify monosaccharides either by pyranose or furanose, identify the anomeric carbon in Howard structures, compare and contrast monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Then students should be able to identify and characterize the glucosidic linkages between oligosaccharides and polysaccharides. It is also expected that students are able to draw the disaccharide in its Howard structures when they are connected by a glycosidic bond. They are also expected to know the difference between homopolysaccharides and heteropolysaccharides. They should be able to compare and contrast the two components of starch, compare and contrast amylopectin and glycogen, identify acetyl and hemiacetyl bonding patterns in carbohydrates. Introduction to carbohydrates. Carbohydrates are also known as sugars. Carbohydrates are an abundant biomolecule. More than 50% of carbon in organic compounds is found in carbohydrates. Plants use photosynthesis to store energy in glucose as simple sugar, and that simple sugar is called what? Glucose. The illustration of how plants use the simple sugars, carbohydrates, to store energy in the form of glucose is as shown in the equation in the slide, where we have 6 molecules of carbon 4 oxide, 6 molecules of water and energy, giving us glucose, and oxygen, 6 molecules of oxygen. Carbohydrates is a large class of naturally occurring polyhydroxyaldehydes and ketones. Monosaccharides, also known as simple sugars, are the simplest carbohydrates containing 3 to 7 carbon atoms. Now, good, we spoke about carbohydrate monosaccharides, and we talked about these monosaccharides being classified either as an aldose and a ketose. Now, what makes a ketose, and aldose an aldose? We have functional groups that have already been determined by the IUPAC and is as such. Now, if the aldehyde is the functional group, it is called or considered an aldose. It is as shown in the slide, where we have the carbon atom here, and it is bonded by the double bond. Oxygen is bonded by double bonds to the carbon, and hydrogen is bonded by a single bond to carbon. Now, if it is a ketose, we just have the carbon bonded by the carbon bonded by oxygen via double bonds, as shown on the slide. A sugar containing an aldehyde is known as an aldose, and a ketone is known as ketose. Carbohydrates are grouped into three classes. Monosaccharides are the simplest sugars and serve as building blocks of larger molecules. Then we also have what? Oligosaccharides. So examples of our monosaccharide is what? Glucose. We also have oligosaccharides containing 2 to 10 monosaccharides bonded together. We also have the polysaccharides that contains more than 10 residues of our monosaccharides. And an example is what? Complex carbohydrate, known as starch. Monosaccharides are polyhydroxy ketones or aldehydes with 3 or more carbon atoms. So these are examples of what? Monosaccharides. This is a 6 carbon sugar, and the functional group is an aldehyde. So this is considered or known as aldohexose. Aldo because of the functional group derived from aldehyde, and hexose because it's a 6 carbon sugar. Now we have the second example. This is an aldopentose. Aldo because the functional group is an aldehyde, and pentose because this is a 5 carbon sugar. So if you count the number of carbon atoms, you find 1, 2, 3, 4, 5. That is why it is called pentose. Now, on the third example, this is a 6 carbon sugar, quite okay. So no doubt it is called a what? A hexose. However, the functional group what is a ketone. Therefore, it is known as ketohexose. Ketohexose. Naming of monosaccharides. Carbohydrate nomenclature is unique to sugar chemistry. We do not name monosaccharides using IUPAC rules. Now, there are these few rules that we use in naming our sugars, and it is as itemized below. Monosaccharide names end with OSE. Monosaccharides can be classified by carbonyl group, either as an aldose, that is, it is an aldehyde, that is the functional group, or a ketose, that means it is ketone, that's the functional group. Monosaccharides can also be what? Classified based on what? The number of carbon atoms. So if it is a 3 carbon atom, it is called triose. If it is a 4 carbon atom, it is called tetrose, and etc. Both, we can also have both aldotriose or ketotriose. Aldo being that it is the functional group, triose indicating that the number of carbon atoms, and os, remember, all monosaccharides end with OSE, os. So this is a table that has put together the type with on this is a table with three major subheadings: type, functional group, number of carbon atoms. So if it is an aldose, it is aldehyde. Remember the functional group. If it is a ketose, it is a ketone. So we can have type a triose, meaning the number of carbon atoms is 3, and like that. Now we can also have aldotriose. Aldo because the functional group is aldehyde. Triose because the number of carbon atoms are 3, and like that. We are having an example here. We can also have aldopentose. It means we can also have ketopentose, depending on the functional group and the number of carbon atoms. So before us, we are these are examples, giving examples of how to name our monosaccharides. This is 1, 2, 3, 4, 5. This is a 5 carbon atom sugar, and the functional group is the aldehyde. So clearly seen, this is an aldopentose. Now below is another given example. The number of carbon atoms are 1, 2, 3, 4. So this is what? A tetrose. Tetrose, based on the number of carbon atoms. Now the functional group is what? A ketone. A ketone. So this sugar can be called ketotetrose. So this is classwork, and I expect you to try this. These are number of, we have carbon atoms here. These are peculiar to sugars. It is left for us to identify the functional groups and name this. So when we come next class, we'll be looking at the names you have been able to give these carbon atoms based on the functional group and the number of carbon atoms. Thank you. See you next class.